In this lesson we're going to look at how a simple DC motor works. Now the DC motor makes use of the motor effect, which is not a surprise, as we've been looking at in the last two lessons. And so before we have a look at that, we're just going to label this schematic diagram of the motor. Okay, so first of all we've got the coil, which is represented by this single conducting loop. Now down here we've got what looks like quite a complicated mechanism. This is called the split ring commutator, so it's like a ring that's been split in half. There's a gap between each side of the ring. You'll notice that. So this is the split ring commutator, a very important part of the DC motor. Now the split ring commutator is fixed to the coil or the loop in this case, and in turn these are fixed to a spindle which is able to rotate. We've got a spindle. So the commutator and loop or coil spin freely, and they are connected to the DC power supply via what are called brushes. Okay, you can see these two are pushing against the side of the rings here. So these brushes are in contact with the split ring commutator but are not fixed to it. So the brushes are fixed, the magnets are fixed, but the commutator and coil are free to rotate around the spindle. So as you can see, the coil is sandwiched between the north and south poles of a magnet. And before I discuss further how this commutator works, let's just have a look and see what happens when I close the switch and a current flows through the coil. And you can see that the current will flow from positive to negative. So the current's coming around here, it's going around the coil in this direction and back in this direction, and so forces will now act upon this coil following the left hand rule. So to work out which way the spindle turns, raise your left hand, and I want you to imagine that you're looking at this setup from this direction. Okay? Right, so I'll just remove that arrow now. So you're looking from this direction, and so which is the direction of the magnetic field? Well, it's going from north to south. So looking from this direction, that's from left to right. So your first finger, that's the field direction, should be pointing to the left. And the current direction, well, looking from this perspective, the current's coming straight at you. So your second finger, which is the current finger, should be pointing directly towards you. And if you look at your thumb now, it will be pointing directly upwards. So that tells us that the direction of the force on this side of the loop is acting upwards, and if you go to the other side of the loop, the magnetic field is still pointing in the same direction. All that's changed is the direction of the current. That's now going this way, so the force will act in the opposite way. That will push downwards. So because the coil is fixed to a spindle, as a result of these two forces acting, the coil will start to rotate, in this case in a clockwise direction. Now then, if it wasn't for this split ring commutator, if you didn't have this here, then all that would happen is this coil would sort of rotate up to a vertical position and it would just stay there. It wouldn't be able to move any further. But what this does is it ingeniously swaps over the direction of flow of the current every half a turn. So instead of just staying in a fixed position, the coil is able to continue rotating. So just to finish off, we can say the speed of the motor can be increased by 1. Increasing the current that's flowing in the coil, 2. By increasing the magnetic field strength, and 3. By increasing the number of turns in this coil. Also, you know that the direction of spin can be changed by swapping the poles of the power supply around. Okay, so these things affect the operation of the simple DC motor.